Imagine your dream car. It could be a sports car, like this one, or it could be a family car, like my car, or it could be actually a utility vehicle, if you are a company. Then imagine that you want to actually use it, so you want to drive somewhere, or you want to start work that you were planning. Maybe you go to visit somebody, or you go to work, anything. And then suddenly this happens. Imagine that how much would you pay to get your car back? If it is just your own car, maybe not so much. If it is a company with lots of cars, or if it is actually some very expensive equipment that got locked, maybe a lot. So, but okay, this is fake, obviously. But is it realistic that this might happen one day? Before continuing, I would like to make a small survey. How many of you are somehow linked to the embedded domain? How many testing or developing? Like, not so much. How many of you are somehow linked to the security domain? IT security, something like that. Okay, not so much. And how many of you are in both? Embedded security. Yeah, there are a couple of people, yes, thank you. So, we know from the news that even well-known, reputable IT companies do get hacked sometimes. And we also know, also from the news, that some cars do get hacked. Currently, while in the IT sector this is big and for profit, people try to break things for profit and to get somehow some benefit, either confidential data or actual money. In the car industry, so far, this is academic projects just to demonstrate the vulnerabilities. But in the IT industry, it also started like that some years ago. And so we can definitely expect that also in the automotive industry, this will evolve into for-profit hacking activities. If you have seen recently the WannaCry ransomware attacks in the news, for example, or maybe your own computer was hacked, you have seen that there are tools available to do this, and it's not so difficult. You can buy a ransomware kit, or maybe even find it. You can buy or find a botnet that helps spread the viruses or your attack. I will talk a little bit more about what happens inside the car, but we know that there are hacks that allow you to get into the car, spread through the network of the car, and eventually you can block the car by software. Then you need to collect payment anonymously so that you cannot be tracked, but that's also possible. And okay, maybe you want to unlock, but that's optional. So let's talk a little bit about what the car what's the difference between a car and a computer center. In a car, there are hundreds of electronic control units, hundreds of computers, all of them different, connected to a network which is also very heterogeneous. So also in the car industry, there's a very strong cost incentive because you are not building 1 or 2 or 10 data centers for your company. You are building millions of units of the same car. So the unit price is very, very important. So you want to reduce the amount of memory, the amount of power, and you want to use the cheapest possible components. A car has to start up in a few seconds. You don't have minutes or a lot of time to start up. You don't have days to set up your system and configure it. And once it started, it has to react very quickly. there are a lot of real-time constraints. When you press the brakes, you want the car braking immediately. Also, a car has a number of external communication interfaces. So you want to connect to different kinds of networks, different external devices, from the USB where you bring your music. Maybe you want a web browser in the car. Maybe you want to update your navigation data, update your software. Maybe eventually cars will want to talk to each other so that they are aware of the traffic situation around them and can either optimize your route or interact in case of a dangerous situation. If somebody crosses a red light in front of you, maybe you want your car to brake. Also, internal connectivity. Traditionally, cars use CAN bus. I will talk a little bit more about that, which was definitely not designed to be secure in any way. Maybe safe, but not secure. The other network, automotive Ethernet, this is also, it was not designed to be secure. There is no protection. Also, compared to a data center, which is locked in a solid building surrounded by security guards, a car is practically open. You do want to stop in a parking space, maybe on the street, and in that case, anybody can access that car. Maybe they will have to break a window to get in the cabin, or maybe they want to have to climb under the car, but they can access the internals of the car. Also, if you take it to a repair shop, you don't know what's happening really there, even if you take it to a reputable repair shop. I very much like the side channel attacks, but probably it's a bit too technical. I will not talk about them. If you want, you can ask me about it. And of course, there is a human factor. While in a security center, anybody who has access has undergone some training, also in terms of security, everything. You cannot really impose too much training on the owner of the car, especially not in terms of security. And they will compromise your car, maybe willingly even, maybe not. So if we look at the networks, at the vehicle networks, we have the wireless, more or less for external connectivity. Why do we need that? Okay, the car will connect to some IoT backend. If you want to have some smart services, it will also connect to the infrastructure, other vehicles, smart signs, smart roads, and also user devices. And you have really no control over those. Internally, the CAN bus, this is the most common vehicle network. It will definitely be around for a while because it's so widespread, cheap, well-known, well-understood. But it is a shared bus among many devices. And there is no source ID, so we don't know who is talking. And once any unit on that bus gets compromised, they can send any message they want. And CAN bus has a very nice priority mechanism where, based on the message ID, lower the ID, higher the priority. This is great if you want to be predictable, but it is bad if somebody wants to hack you. So coming back to the demo, or the screen I showed, this is actually was a proof of concept exercise done by eScript, which is a security company in the Bosch group. Basically, they took an Arduino device, any screen, and a real dashboard, and they showed that it is possible to hack automotive components and to establish this kind of lock mechanism. So a ransomware in the car is feasible, at least. They were using really tools that are available on the darknet and nothing really fancy, and not much insider knowledge. Also, if we think about a car, we have to consider its full life cycle, from the development, where developers will definitely introduce some bugs. We can even predict the number of them. They will implement some features which are inherently unsecure. And okay, we will need to find ways to secure them. But also, since the development is done by a very large supply chain, information leaks are also possible. Even if nobody is supposed to leak, but there are so many people involved in the development of basically any product that you have to expect information leaks. Then coming to manufacturing, again, lots of open questions. You need to manage all the keys of all the components. You have to push that through all your suppliers. You have to manage the configuration control. There are a number of questions that you need to address in the production phase. Okay, once the car is on the road, what happens? It will need some regular maintenance, and you don't want to assign monopoly of maintenance to the manufacturer of the car, so you want to have independent repair shops. But how can you ensure that they do follow the security requirements that were established in the development phase? Also, how you can protect the access to these diagnostic services and all that. Also, if you assume that there will be security problems, you need to ensure that you can patch them, and you need to patch them quickly. So, over-the-air update is definitely a must. But again, that needs to be protected, because if you allow flashing over the air, you need to be very, very sure that it's not compromised. And then long-term maintenance. Okay, you develop the car maybe 5 years, you produce it maybe for 10 years, and then you need to support it at least 15 years. And now we are talking 30 years. So towards the end of the life cycle of a car, if you need to introduce a patch, you need to patch software that was developed 30 years ago. Anybody was around 30 years ago? What kind of software were you using? I was using 20 years ago Fortran, and I doubt that anybody could patch. Well, maybe Fortran is still not that old, but 30 years is enough that your compilers have disappeared, your build environment has disappeared, and the know-how of the team has definitely disappeared in 30 years. And okay, if you want to use the cloud-based services, which are very nice and very useful, you will have to make sure that they are protected in terms of security and also in terms of privacy. So if you want, for example, to accept information from other cars, you want to know that those are real cars, but also you don't want that your car can be traced everywhere you go. So you need some mechanisms to solve that. But it's not all lost. There are some ways to protect, and there are some good signs already. We know in the automotive industry, we know a lot about functional safety. And there are established development methods, established requirement traceability methods, failure modes, and effect analysis. So there are very good methods that are not designed for security, but are designed to produce good quality code and good quality solutions. In classical IT enterprise network security, again, we know the other side. So we know security and not so much safety, but security is a well-known established business in a different environment, but there are best practices and coding rules analysis, threat and risk analysis. So there are established methods which we can use. And now we can combine the two, hopefully. And there is a lot of work going on, a lot of thinking going on, how to combine these two, in principle different, but very much connected areas. Also, so the solution is to apply the best practices, or at least some good practices that are combined from these two different domains. We know that we will need a legal framework, we know that we will need some organizational measures, and we know that we have to use state-of-the-art technology. But this is all, we just need some healthy paranoia, and then I think we can do it. So I listed some of the aspects of the legal framework, technical aspects, organizational aspects, but I would rather not read you the list. You can ask me any specific if it's interesting for you, but I would rather go into more the technical aspects, since this is a technical conference. First of all, domain-based architecture. This was not invented for security. This was intended for scalability, but it has very good effects on security as well. The idea is that in a car you have lots of different systems, lots of different domains, and basically you want to structure your internal network such that for each domain you have more or less one responsible unit, electronic unit, or let's say one responsible computer, which is connected to everything that's in that domain. And then, for example, domains could be the transmission system, the powertrain, the chassis, or the body computers, or body domain. Infotainment is an important domain in this sense. And all these domains have their own controllers, and like this, they are more or less isolated. And but they do need to communicate, but we do that through a central gateway, and this central gateway can enforce the isolation as needed, can serve as a firewall, and only pass messages that are needed. It can enforce virtual networking, so that only information goes only the way it is intended to. And we would use automotive Ethernet between the gateway and the domains. And like this is a point-to-point connection where you know where the information is coming from. And while it is possible to spy on this and attack it, but it's not so obvious. And another aspect is to use a hardware security module, which is in principle, relatively cheap piece of hardware that can be embedded into the controllers, microcontrollers, or as a separate component, which has some functions like secure key storage, some functions that accelerate the calculation of complex security protocols, so cryptography and so on. Also trusted environments to help arrange this safety or security. So, as the last part of my talk, I would like to present what we in our team did as a small exercise. So, you need to know that Bosch is a big company. Within Bosch, there are people who are specialized in many different domains, among them security. But also, there is a very, very strong spirit of innovation, and entrepreneurship is very much encouraged. So, my team is a team of conformance testers. So we test all the communication networks in the car. And we have accumulated quite a bit of expert knowledge on those networks. And the next logical step for us was to say that, okay, once we know the networks, we want to make them secure, or at least we want to participate in the effort to make them secure. And since we are testers, we could do security-related, so penetration testing. And okay, how do I build up penetration testing know-how from zero when the whole point of security testing is based on trust? The whole point of security is that you need to somehow manage the trust. And if I don't have expertise, then how will my customers trust me to do this for them? So we started small. We took a small Raspberry Pi device, just anything, any computer. We installed an open source Linux, automotive Linux development kit, which was proposed some years ago to start development in automotive domain. And we ran an off-the-shelf open source penetration test suite against them. We took Kali Linux and run a port scan. Okay, with the port scan, basically you're looking for open ports where your device is accepting connections. And we found that, okay, this dev kit was accepting connections on SSH port, which, okay, it's probably vulnerable, but it's not the target of our investigation because you will definitely not keep it open in production. You will not need it in the car. And the other was a diagnostic lock and trace port, which is a standard protocol that you use for diagnostics, logging, development, whatever. But again, this is not supposed to be open in production. Nevertheless, we investigated the commands that it accepts, and yes, we found some commands which it should not accept, or at least which open a security problem. And we found some debug information leak, like build information, usernames, and so on. But again, this is supposed to be closed when the device goes into production. Okay, we didn't find much else, but again, we were testing an empty shell. So we were testing a development kit which had no functionality. So it definitely needs no open ports to provide no functionality. So anyway, the next step will definitely be to test an actual device, an actual product. I will not be able to talk about that too much, since I'm not allowed to talk about products in development. But we see that even in any product, we will need to test it once it is configured for production, because that's the state that it will be in the car. And we need to check whether those ports that are supposed to be open during development are really closed when you go into production. And definitely, there's a long way to go. Okay, to conclude, I hope I convince you that car hacking is a real threat and a real possibility. I hope I convince you that protection is not easy. It's not enough to take what you learn in IT security and apply it to the car. There are some open questions. There are some challenges. I didn't talk about it, but legislation and organizational measures are very important to ensure that you do things correctly and that you can respond to threats. And also, I hope I convince you that the technology is available. We just need to learn to use it and use it well. Thank you.
Thank you very much, Ákos. We have one question, a very good question actually. Do you have some example of some serious security breach that the testing team found?
Not like that. So I know about this security or about many security breaches that were published. And these were typically found by academic teams who spent a lot of effort, years of effort, to break one specific car and show that it is vulnerable. And there are many of those, several different cars. The most famous is the Jeep one. The most recent is maybe the Tesla one. But there are many of those. And basically, as soon as your car has a connection, it is very likely that it can be broken into.